Mr. Ahmed here to start up Chapter 3 for Intermediate Algebra. Our goal for Chapter 3 is going to be to graph linear functions. So kind of a long chapter. We'll have 7 total sections by the time we're done. Today we're really going to work on identifying functions and domains and ranges. So, essential question. First off, what is a function? And how do I identify the domain and the range? So, goal for today, what is the function and how do I identify the domain and the range? Going to make this a little bit smaller. So a relation is a set of ordered pairs. And examples of these ordered pairs would be 3, 2. Typically for us, our ordered pairs will come in the form x, then y. We will keep pretty much everything in the coordinate plane. A mapping, I determined how each x is related with y. So for an x value, we are going to end up with a y value. For instance, if x is 3, it could be mapped to y equals 2. X could be 5, and then y could be mapped to 8. So if x is 3, y is 2. If x is 5, y is 8. That is a mapping. Graphically, if we indicate our relation graphically, we'll plot each point on the coordinate plane. And you should have plotted points in the past. But here, if I were to plot my 2 points, 3, 2, I would go over 3 for x and up 2 for y, and over 5 up 8 for my second point. So that is how we would graph our points. So this is the point 5, 8, and this is the point 3, 2. So we'll have to do quite a bit of graphing this chapter. Table form. Each point is listed in an x, y table. So our x's are on the left, our y's are on the right. I'm going to list some of the points out. We had 3, we had 2, we had 5, we had 8. We could also have -3, -4. I'm going to add those 2 points for up above. I could have my -3 mapped to -4. And if I plot the point -3, -4, it would be right here. So those are our 3 points that we are working with. The domain is the set of all inputs. Typically for us, the inputs are going to be the x values. The example of our domain of all of our x's for the numbers we've been working with are 3, 5, and -3. And the range is the set of all outputs. The outputs are typically going to be our y's. So in our case, we had 2, 8, and -4. Those are all of our y values that we had going on. A function is a relation in which each x is paired with exactly one y value. Each x can only go to one y. So each input can only be sent to one output. Okay, so if your x repeats, that's typically going to be a non-function. Okay, so each x can only be sent to one y. The independent variable is the variable that represents the x value of our function typically, and that is the input. And the dependent variable is the variable that represents the y values typically. That is our output. Independent and dependent is what comes out. Okay, it depends on the value of the independent variable. So our x goes in, y comes out. So determining if a relation is a function. So when we look at the ordered pairs, or the mapping, or the tables, do the x's repeat? So if we see more than one x, it is typically not going to be a function. If there's only one x value, yes, it will be a function. Graphically, we'll do what we call the vertical line test. We will look at the entire graph and we draw a vertical line through it at any spot. If that vertical line only crosses once, it is a function. If it crosses more than once, it is not a function. So realistically, going to look at some examples here. So our first one is mapped. Do the x's repeat? I see a 1, a 0, and a 3. So they do not repeat. So yes, it is a function. The domain, every x value, 1, 0, and 3. And the range is 1, 2, -2. Okay? We have listed out the domain and the range. The next one, number 2, is it a function? Does x repeat? No. So yes, it is a function. X's are 1, 2, and 3. Domain is 1, 2, and 3, and the range is 2, 4, and 6. All right, now looking at a graph. That vertical line test. Now, like I said, the vertical line isn't just one vertical line, because I could draw a vertical line here and it only crosses once. But here, if I draw a vertical line, it crosses twice. So since it crosses twice, it is not a function. Okay? It's not a function, but I'm still going to list the domain and range on this one because it's graphed. So the domain is every x value. So x is going from 0 all the way over to 10. So the domain are all the numbers of x from 0 to 10. And I listed that as a compound inequality. X is in the middle, x is greater than or equal to 0, and x is less than or equal to 10. The range, all the values of y. So the y values in this one go from all the way down to the bottom. -2 is the smallest y, and the biggest y is 8. Compound inequality again. Y is between -2 and 8. Okay? And lastly, another mapping. Do my x's repeat? Well, here, -1 is being sent to 4 and -1 is being sent to 5. So x is being used twice. X gets sent to 2 different spots. If that occurs, it is not a function. X's repeat. The domain in this case, I'm going to list it out just for some more practice. But the domain is -1, 0, 1, and 2. The range goes 4, 5, 6, and 7. And we have completed it. So listed the domain, all the x's, listed all the ranges. And this one, not a function. All right. Looking at some ordered pairs. Does x repeat? 1, 2, 3, 2. So x repeats. It is not a function. The domain are all the x's, 1, 2, and 3. The range, all the y's. Looks like we have 2, 3, 4, and 1. I want to put 1 first. 1, 2, 3, and 4. We listed all the y's. Next example. Do the x's repeat? I have a 5, a 7, a 9, and an 11. So x's do not repeat. Keep in mind in the ordered pair, x comes first, y comes second. So it is indeed a function. The domain, all the x values, 5. I'm going to put x here, range y's. So we have 5, 7, 9, 11. The range, 2, 3, and 4 is twice, so I'm only going to list it one time. Okay? The next one is a vertical line. So obviously if I draw a vertical line on the graph through my vertical line, it's going to touch it all the time. So this is not a function. The domain in this case are all the values of x. X is only 2. The range are all the values of y. Now y goes from -infinity all the way up to infinity, so it keeps going forever and ever and ever. So the range is all real numbers. That's how I listed all real numbers. You could also say it goes from infinity to, negative infinity to positive infinity. The symbol for infinity is a sideways 8. Okay? So, it goes up forever, goes down forever. Next one, looking at the graph, drawing our vertical line. Now if I draw a vertical line anywhere on this, crosses once, crosses once, 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 once. So since the vertical line only crosses the graph at one point all the way through it, it is a function. The domain, how far to the left does it go? Goes on forever to the left. How far to the right does it go? Goes on forever. So the domain is all real numbers. And the range, now it goes down forever, but not up forever. The biggest value of y is right here at 2. So y is less than or equal to 2. Because all the values of y can go down, 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 but it can only go as high as 2. And lastly, our word problem for the day says the function a equals negative 4b plus 14 represents the number of A avocados you have left after making B batches of guacamole. So in this case, our input is A, our output is our input is B, our output is A, okay? So identifying the independent and dependent variables is our first goal. So putting in, well, we are going to make a specific batch of guacamoles, so that is the independent variable. And the dependent variable is how many avocados that we have left over after we're done, okay? So that's our dependent variable. Now, the domain is 0, 1, 2, and 3. What is the range? So for us to figure that out, I have to put these in. So I'm going to make an A-B table, or a B-A table. The domain, that is our input, so that has to be the B's. Our output is the number of guacamoles left, A. So input on the left, output on the right. I have to put in 0, 1, 2, and 3. And we're going to see what the range is. So when I put in 0, A, the number of avocados left, is equal to negative 4 times the number of batches, B, that's a B, plus 14. So that means I'm starting with 14 guacamoles. So if I make 0 batches, well, when I take negative 4 times 0, I get 0. There's 14 avocados left. If I make 1 batch, negative 4 times 1 is negative 4 plus 14. I have 10 avocados left. If I make 2 batches plus 14, negative 4 times 2 is negative 8 plus 14. That is going to be 6. You should see the pattern here. It's going down by how many each time? Down by 4. So my next one should be 2 when I put in 3. Negative 4 times 3 plus 14, negative 12 plus 14 is indeed 2. So the domain is 0, 1, 2, and 3. The range, I'm going to list this down here, is 14, 10, 6, and 2. So that's kind of all we got for today. This word problem was a bit challenging, especially with identifying the independent and the dependent, but otherwise fairly straightforward. Just keep in mind the vertical line test for the graphs, and do the X repeats for the ordered pairs and the maps. Have a great rest of the day.